let's move on to our last cohort presentation. This is Henrik from Denmark to talk about the DocX cohort. Henrik, please go ahead. You have 5 minutes.
You hear me, Michelle?
Yes.
Everyone, yes. Thank you, Michelle. I would present the Danish occupational cohort with exposure data, or just DocX in everyday speech, that was established 2 years ago. The cohort includes all gainfully employed persons living in Denmark since 1970 until now, until 2015, but it will be updated. It includes 5.4 million persons, 45% women, and all they have a national ID number that allows linkage with a lot of national registers. They are included from the first year of employment, 1970, the earliest, and the data set includes between 2 and 2.9 million persons in employment yearly. And until now, 91 million person years have been cumulated by these participants. The DocX database consists of 3 parts: the occupational and industry register that includes all participants in the cohort, by the ISCO code that occupation is coded in this register. We can link with job exposure matrices, and by national ID numbers, we can link with individual level information on age, sex, cancer, hospitalizations, etc. in several national registers. And this allows us to study what we are interested in, the association between exposures at work and different health outcomes. The Occupation and Industry Register is located at and based on information from Statistics Denmark. And for each year of employment, it holds information on occupation and industry. And the sources of this information are tax records and reports by the employers. And occupation is coded by ISCO 88 for all years of employment at the 4-digit level, and it covers 372 occupations, as you can see. And industry is coded by the NACE 2007 versions. And the cohort has an 80% coverage at the 1-digit ISCO 88 level, while the coverage is somewhat lower at the 4-digit level. 10 different GEM sets have been developed, 4 based on expert ratings, 3 based on survey data, and 3 based on statistically modeled measurements and expert ratings. And based on expert ratings, if we start from the top, there are GEMs on loads lifted and other mechanical exposures affecting the back and the lower limbs, vibration, that is whole body, and arm vibration. There are GEMs on shoulder elevation and other exposure affecting the shoulder, and also on diesel, formaldehyde, and organic solvents. And for each of them, you can see the calendar period covered, and the last one you can see goes back to 1945. And this is actually a further development of the Finn gem that most of you know, I think. Then we have gems on psychosocial demands and other psychological factors, physical exertion, and smoking, alcohol, BMI, and other lifestyle factors. And they are all based on survey data, And you can see for the lifestyle gem and also for the others, actually, that estimates can be provided for, specific estimates can be provided for sex and age group, and for the lifestyle gem also by calendar time. And then finally, we have three quantitative gems based on measurements and expert modeling covering noise, daytime light levels, wood dust, and endotoxin. Then we have individual level data on demographics, age, sex, and several other health aspects, as you can see, in addition to education, income, and so on. And the number of possibilities is almost endless. And I can say of current interest is linkage to all PCR tests done for SARS-CoV-2. And yesterday it was 42.5 million tests in that data set. And what has been found? Bunde and all studied acute myocardial infarction in relation to physical activities. They used the gem on loads lifted to quantify physical activities, and they used first time myocardial infarction hospitalization as a measure of incident myocardial infarction. And they actually showed a nice exposure-response relation between physical activities, that is heavy lifting, and risk of myocardial infarction. And this paper contributed to the ongoing discussion on the opposite effects of physical activities at and off work that is going on. Regulus and all studied the association between job strain and coronary heart disease. They used the DocX gem on job strain and identified incident coronary heart cases in a similar way as Bunde did, and they also showed an increased risk of coronary heart disease following job strain. And a major strength of this study was that it was not dependent on self-reports that might have biased some of the earlier studies relying on such exposure information. For several years, there has been shown an association between exposure to crystalline silica and systemic sclerosis, rheumatoid arthritis, and other autoimmune rheumatic diseases. However, there is limited data on the exposure-response relation. In this study by Bodigor and colleagues, they used the SynGem quantitative estimates of crystalline silica to characterize exposure and first-time hospitalization for autoimmune rheumatic diseases. And they showed a nice exposure-response relationship that actually was used for the recent re-evaluation of the Danish TLV values. And you can get access to the DocX data, but there are some requirements. The project has to be within occupational medicine, and you have to stay at a Danish research institution granted access to Statistics Denmark. And there are some other details, and all this information you can find on the homepage of the DocX project, and you can read more about it in the Cohort profile that was published in the International Journal of Epidemiology 2 years ago. Thank you. That was all from me.
Very nice. Thank you very much, Henrik. Are there any questions for Henrik on the DocX cohort? I know that it's an enormous resource. I think that has a great potential, and I know that there's a lot of collaborations planned with the cohort as well, which is wonderful. I don't see any questions, so please feel free to chat with Henrik in the chat. Thank you, Henrik.